we're going to run a pod with one container in it. Specifically, we're actually going to run this service where port 22 is exposed, and we're going to run one container called CCv0 SSH. We're pulling this container from Docker Hub, and this container is encrypted. This is the Docker file that we use to build the container. This is an SSH container, so it's going to run SSH. We're also going to set up a public-private key pair for the container, and we're going to add a key to authorized keys. So my public key is going to be in authorized keys, so we will be able to SSH into this container. This is what the container actually looks like if you were to download it. You can see that if you look at one of the individual layers, you can see that it is an encrypted layer, and you can see some of the annotations that are used to specify the key provider that we're going to use, and then the parameters that get passed to the key provider. So on our host, we can check before we start anything all the QEMU processes that are running. So far, there aren't any because we haven't started up this pod yet. Once we start the pod, we'll see that a VM is spun up to host it. Also, a word about measurement. Our goal is not just to blindly supply a container to the virtual machine, but we actually get a measurement launch attestation of the VM and the enclave that we're running, and we verify that before we release the keys. So we have something we call a guest owner proxy, which is key broker server. It uses this key sets file to determine whether or not a measurement is valid. You specify an allowed digest, which is the hash of the firmware, as well as a few other components. We also map a key set into a group of keys. In this case, we only need one key because we only have one container, where each layer is encrypted with a separate symmetric key, but where all those keys are wrapped by the same key, which is known as key ID 1 in this case. These are SEV-specific parameters. You can set a certain allowed policy that we verified when you do the measurement, and the API major and minor version. You're probably going to want to set this not to 0 in the real world, and the allowed build ID. So like I said, SEV-specific parameters that help you verify exactly what the node, how the node has been provisioned and set up. This allowed digest can be calculated with this tool. So want to show that you specify the firmware, you also specify the kernel, the initRD, and the command line. So all of those things are a part of the launch measurement, and that coincidentally is the footprint of the Kata agent. So you know exactly what Kata agent is running, exactly what the environment is like before you inject the containers. That's obviously not a coincidence. We'll see over here, this is where the guest owner proxy is actually running. We'll see when we start the container in a second that it's going to verify the measurement, and hopefully that the measurement will be validated. So we'll apply our service here, and we can see that now we have a QEMU process running. So that's where the pod is going to live. We can also see that we have now validated the measurement when that booted and injected the secrets that we'll need. So the measurement was valid. Now we can see we have a new pod that is spun up. It's running. We can get more information about it. You can see we, pulled the image from inside, and we created the container and ran it, obviously. So a crucial thing is that we can try execing into this container, and we'll see that it's not going to be allowed. So exec would potentially be an interface that a CSP or the host could use to get into the container, but it's been disabled. You can see exec process is blocked. This is a disabled VA configuration file that's in the initRD. The initRD is part of the measurement, so the guest owner can be 100% sure that endpoints that they want to disable will not be accessible to the CSP. If you want to connect, not as the CSP, but as the guest owner into this container, then you use SSH. So here we'll specify the same identity that we put into the containers, and then we will just use some magic to get the correct IP address. You can see, since this is the first time we're connecting to it, we actually get the fingerprint of the public-private key pair inside of the container. And this should match the fingerprint that you get when you first run the Docker file over here and build the container. That should match exactly, so you know that you're talking to exactly the container that you think you are. Now you can connect, and you can do something like this to get some information about the machine and to confirm that you are running inside of an encrypted enclave with AMD SEV. So overall, we are pulling the images inside of the guest. We're pulling an encrypted image inside of a guest, and we're locking down the API between the host and the guest to provide confidential containers on AMD SEV hardware.